All right, here we have this question here. What would be the result of attempting to compile and run class B? Okay, so here you have class A with a final int I assigned to 10, and then you have a class B which extends it. And then you've got an int fi is assigned 15. Now, this is hiding this one up here. The fact that this one is final has no effect. That's not a problem. It's not like you're going to get a problem because that's a final. It's in a different class. It's a subclass, and it's hiding it. No problem. We then create a B reference referring to the B object, and then we say b.fi. Because we're referring to the fi in B, the type B, we're able to change it. That's okay. So we then go along and we output 10 because we just changed it there. But as with all data, you can cast up the tree to get a different data value. In other words, the hidden one, and that is 10. So it's going to output 20 and then 10, which is that guy there. We'll get the next one. So we have here a car and then a sports car, which is underneath that or inheriting from it. So we'll just go and we'll have a look at that in the viewer, the document viewer. So I have it preloaded here. That's the code there. And we'll just draw that up in a UML diagram. So we have car is the base class, and extending from that is sports car. Now, car has a gear ratio, which is a value of 8. And the gear ratio in sports car is 9. And there is a polymorphic method in both accelerate. So this one is overriding this one. And we have a car reference referring to a sports car object. Okay, then we have to output c.gear ratio here and c.accelerate. So when you're dealing with data, which is what we're talking about here, c.gear ratio, when you're talking about data, you examine the type of the reference. C is of type car. So you go and you get the gear ratio from car. So it's this one. This, however, the accelerate is an instance method. So it's a polymorphic instance method. So you look to the object. So it's over here in sports car. So you execute the accelerate method in sports car, which is accelerate : sports car. So it would be 8 accelerate sports car is the output for that particular question. Is that okay? Okay, let's go back to Enthuware. Okay, what will be the value or the result of compiling and running the following code? So you have a class base, and then you have a get value method which returns an object. Then you have a base 2 which extends it and it returns a string. Okay, and then you have base B is assigned new base 2. Okay, so we just look at that in the viewer. Okay, so we have a base and then a base 2. We have object get value. So that's the return type. And the subtype has string get value. And that's the object or the topic of this particular question. You have an instance method in a subtype. And since Java 1.5, covariant returns are allowed. What does that mean? It means that you can return a subtype of the parent. This is okay in this case because a string is an object, because the string extends from object. Now, if it was a primitive like an int or a double lowercase, then all bets are off. It has to match exactly if you're overriding. Okay? But if you're putting in a class or an object type, then you can put in subtypes in the overriding method. And then we've got base B is referring to a new base 2. So that's a polymorphic assignment there. So when you say b.getValue, getValue is an instance method. So it will go and it will execute the getValue in the type over here of the object. So it'll execute it in here, and that's the one that returns a string which says hello. So the answer to it is it will print hello. All right, so we have class game, which is a play method which throws an exception. We have soccer, which is a subtype of game, which has a play method, which has a string. So the first one here has no arguments coming in. So there you can see the play, no arguments. This one has a string. So not overriding, we're overloading here. Okay, then we come down to the test class, and main throws an exception. And there's game, and is assigned to new soccer. And then you've got a soccer reference, and that's going to be, the game reference is going to be cast to soccer to pass it in, because there's a lot in this question that's very good to understand. Okay, upcasting, downcasting, what you can call, what you cannot call. Okay, so remember, what you can and cannot call with a reference is determined by the reference type. And that's what this question is examining. Okay, so we will load it up on the viewer and the document camera, and we'll talk about the code then. So what it's going to look like in UML, we have a game type at the top of the hierarchy. Subtype is soccer. So soccer is a game. The game class or type has a play method, takes no arguments. Soccer has a play method that takes a string. Okay, then further down in the code in main, we create a game reference, G, referring to a soccer object. Now, can we say that? Yes, a game reference can point down the tree, because the soccer class will have inherited the play because of inheritance, and it's added its own one. And that's what I'll put in as well in the diagram, is the soccer type has a play method. It inherited it. And that's key to this particular question. So we create a game reference, and it's referring to a soccer object. That's the first line. The second line down here, okay, is take that G reference, downcast it to a soccer, and put it into a soccer reference. Now, do we need the downcast? Yes, because you're going from a game reference down to a soccer. You're coming down the tree. Okay, you need a downcast. So we're casting the G reference to a soccer object S, soccer reference S. What's G referring to? A soccer object. So that's what you're going to get at runtime. Is that going to give you a class cast exception? Absolutely not. S is referring to a soccer. So the soccer reference is referring to a soccer object. That's okay. So it will not compile as it is. Well, that's wrong. It does compile. It will throw an exception at runtime. No, we saw that that's okay. This line here equates to that arrow there. The next one, g.play at 1 and s.play at 2. The question is, which of the given options can be inserted at line 1 and line 2? So g.play at 1. First of all, you have to check, is there a play method in the type of G? What's G a type? What's its type? Game. Is there a play method and game? Yes, there is. That's okay. And s.play with a string at 2. S is of type soccer. Is there a play that takes a string in the soccer type? Yes, there is. So that's correct. The third one there is okay. What about the next one? G.play at 1 and S.play at 2, correct. That's okay as well, because as I wrote in here in the red, the soccer type has a play method with no arguments that it inherited from game. We already saw that the G.play has that already. The last one is G.play passing in a string. Okay. G.play passing in a string and S.play passing in a string. Well, we know S.play passing in a string is okay, but G.play passing in a string is not okay. Play taking in a string with G, using the G reference. The G reference, what type is it? That determines what methods you can call. So G is of type game. Game has only got a play with no arguments. It does not have a play with a string. So that will not compile that there at the bottom. So it's select two options, and they are the third one and the fourth one there. Which of the following are valid declarations inside an interface independent of each other? So the void compute, yes, that's fine. There's no problem with that one. Note that it's public by default. Public void compute, same thing. That's fine. They're the two options, so the other three are incorrect. Final is incorrect here. You can't have a final method inside in an interface, otherwise how would you implement it? If it's static, it needs to have a method body, curly brackets. And protected is incorrect. They're supposed to be public. They're supposed to be public. Okay, what if anything is wrong with the following code? You have a test class which implements T1 and T2, and the interface T1 has a constant value set to 1 and a method M1. And then you have an interface T2 with a value set to 2 and the same method void M1. Here you implement the two of them and you've got the method implemented as you would need. Actually, there's nothing wrong with this code at all. Okay. Now, having ambiguous fields or methods does not cause any problems by itself, but referring to such fields in an ambiguous way, okay, that causes a compiler error. So you cannot say system.out.println of value there, okay, because it will be ambiguous. There are two value definitions. But what you can do is just cast it like that, and you'll get to the one that's in T1 there. Note that the method doesn't matter. You don't need to use a cast because the code only exists up here in this one. You've only got the definition up here, whereas you've got the actual code there. The declaration is up here, and you've got the code there. Okay, now this particular one is about when you call the s.get class. What is output? Well, simply, it's the class of the object that that reference is referring to. So in this question, S is a string. So The get class is, it's an object, it's an object of type string, and it'll be the full object path like java.lang.string. Okay? List is an array list. The object is an array list. The reference type is a list. So the get class is the object type, so it's an array list. So it's that particular one there. Java.lang.string and java.util.ArrayList. That's what the get class method gives you. What is the type of the object? Okay, this particular one, we're going to need a diagram to explain this one. We have an ABCD and an MNOP. And then we have instance and class variables in the two of them. So this is number 8. Okay, so we've got, and this is the way I would tackle this type of problem. I would say, okay, we've got our ABCD is the top of the hierarchy. And we've got an instance variable X, which is set to 10. And then we have a static Y is set to 20. And it's static, so I underline it. MNOP extends from ABCD, and we've got an instance variable X set to 30, and a class variable Y set to 40. Now, this piece of code down here, new MNOP.X, that's creating the following in memory. You have an MNOP reference, which you have no name. You don't know what to call it because you didn't store it. And it's referring to MNOP, the object, because that was the one that you did a new on. And you want the X from basically there. Now it's the data, so you refer to the reference type. So this is easy enough in the sense that it's the reference type and the object are the same. So you could actually be looking at the wrong one and still get the question right. But you'll see in the explanation it goes a little further, making it a little harder. And I would anticipate it would be a little harder than this. MNOP is the reference type. Therefore, we want the X value from MNOP, is this guy here. And then the next part of it over here is the same idea, MNOP. So you get a duplication of this and you get the Y from there as well. Okay, so it's 30 and 40. Now, what it says here is access to static and instance fields and static methods depends on the reference type and not the object type. Okay, data and static methods, you look to the reference type. Observe that this is the opposite of what happens in the case of instance methods. Instance methods, polymorphic methods, you look to the object. Non-static methods. Okay, so that explains it. However, had it been something like ABCD, well, let me just go back. And we want 30 and 40. Evaluate it. And then you'll see here, down here at the, had it been ABCD referring to the object MNOP, now A.X means give me the X from the type of A, which is ABCD. And the same for Y. ABCD's X and Y would have been accessed because A is of type ABCD, even though the actual object is of type MNOP. Okay, which of these is a proper definition of a class that cannot be subclassed? That's fairly straightforward. Final. Final cannot be subclassed. If you make a method final, it means you cannot override it. If you make a class final, it means you cannot extend it. So you're modeling a class hierarchy for living things. You have a class living thing, which has an abstract method reproduce. Now you want to have two concrete subclasses of living thing, plant and animal. Both do reproduce, but the mechanisms are different. What would you do? So you're going to have a parent, which is your living thing, and it has a method reproduce. And then you have two subtypes, plant and animal. They both reproduce as well, but they're slightly different. And the answer here is reasonably straightforward. You override the reproduce method in plant and the animal classes. It's worth looking at the answer here because it brings in overriding versus overloading. This kind of scenario where the subclass has the behavior of the base class but implements it in a different way is called overriding. Here, both plant and animal reproduce, so they have the behavior of the base class, but they do it differently. So you have to override the base class method in the code. Inheritance is always involved when you are overriding. Overloading is quite different. When you want to do similar but not the same things, but the inputs are different, then you overload a method. For example, you may have two add methods. This add takes in two ints, the other add takes in two complex numbers. Here both are doing similar things, that is why they're called add, but their inputs are different. Both are two entirely different methods. Okay, except they have the name add, and there is no inheritance involved. So that's inheritance and overloading. Okay. Okay. This particular one, question 11, we're going to need a UML diagram to answer this one. Okay, we have A is the parent, the base, and we have a public I, which is 10. Plus is for public, private J minus 20. B is the subtype, and has a private I, which is set to 30. And a public K, which is set to 40. And then we have C as a subtype as well. Then we have a C reference, C referring to a C. Now, we come along and we try C dot I. So C is a reference of type C. There's no I, so it tries to go up like that. That direction. So it's going to come across I, which is private. That's a problem. That's a problem. C.J will do the same thing. None here, goes up, and that's private as well. Not going to work either. Two compiler errors. C.K, well, that's okay. That's 40 and it's public. So that's not going to be a problem. So the answer is the second one here. The code will print 40 if 2 and 3 are commented out, as we just saw. If 2 and 3 are commented out, it will print 40. So B's I hides A's I. This I here hides the I that's up here because you're going up that direction. And since B's I is private, you can't access A's I unless you cast the reference. And I have a bit of code written here as well for this one. So this is the idea here. So yeah, this one is hiding that one up here. So this is the type of error you're going to get. I has private access in B. If I do that one, J has private access in A. And then if I want to actually get at the I value up here, using the C reference, just make sure I cast it. I need to make sure those set of round brackets that are in yellow are done first. If I don't, the dot operator, which is right beside it, will have a higher precedence. So if I do this, see, I've got the same problem. I has private access in B. So I have to make sure that the cast is done first by putting it in round brackets. Okay? So just be careful with that particular one like that. Okay, so 1144. Fairly straightforward one. Consider the following interface definition. Any field in an interface is implicitly public, static, and final, whether the keywords are present or not. Okay? So they're all the same. And they're all okay. There's no problem. Okay? Public, and then an int, static, int, public, or final int, public static int, public final int, static final. You can mix them up the order, and public static final. That's typically what you say. They're all the same though, whether you put in the keywords or leave them out. The default for data is public, static, and final. Which of the following are valid declarations inside an interface independent of each other? Well, the first one is a default, so therefore it should have a method body, curly brackets, and it doesn't. So that's not right. The next one is, well, it's public, yes, void is a return type. It's abstract because I haven't put in default or static, which means there shouldn't be a curly brackets, and there isn't. That's okay. Static must have a method body, and it does. That's okay. Static, void, compute. Static must have a method body, and this doesn't. So that's not right. And default and static don't go together. They're mutually exclusive. You have one or the other. Okay? Because the default is expected to be, is an instance, is always an instance method. So it can't be static. So that's the answer to that one there. Okay, 2.1149. Okay, we're going to need a UML diagram for this. Okay, so we have an interface called MyIFace. And C implements it. And then we have A, and B is a subtype. And B also implements the interface. Okay. And we have a few objects, A referring to A, B referring to B, and C referring to C. Now, the first one here, B is assigned C. Well, that's not going to work because if we look at there is no relationship between B and C. Okay? B is not a parent to C, C is not a parent to B. There's just no relationship between them. And so the second one was the same thing. C is assigned B is the same thing. And this fourth one is the same idea. Anything going between B and C is not going to work either way. Okay? This one here is going to work because you're going from right to left. C is a MyIFace. You're upcasting to the interface. And if you're ever confused about it, well, then what you should do is put in something like vehicle and then put in car. Can you say vehicle V is assigned new car or whatever the car is reference? Yes, you can, because every car is a vehicle through implementation inheritance. A car is a vehicle. So the third one is right. But I want to talk a bit more about the bottom one, where it says B is assigned A. It's worth talking about that for a minute. So B is assigned A. So what you're trying to do, if you read it from right to left, you're trying to put a reference A, which is of type A, into B, which is of type B. So you're going from A down to a B. And I emphasize the word down. So you need a downcast. This is a compiler error. That is a compiler error, to be trying to put an A into a B. Okay? Compiler says, oh, hang on a second. That A could be referring to an object of type A, and we cannot have a B pointing up here. But the A could be referring to a B or a subtype of B. An A reference can refer down the hierarchy. So the compiler could come along and force you to do this. Okay? So you cast it down. Okay? So the compiler is happy because you're overriding it essentially. Okay? Now, your concern is, will you get a class cast exception at runtime? Well, that depends on what A was referring to. And according to the code here, A is referring to an A. So you would end up with B. Well, if it allowed this bit, basically what's happening here on the right-hand side is there's going to be a temporary B reference referring to whatever A is referring to. So you will end up with a B reference pointing at an A object, and that's not allowed. That's just another bit I wanted to talk about, that particular line at the bottom. So that's when you get your class cast exception there. When you have a reference pointing up the tree or referring to a type up the tree, B referring up. And that's because B could have extra methods, nothing wrong with that, but A won't have them. A won't have them. That's why it's okay for A to refer down the tree, because through inheritance, B will have at least the same methods that A has. May not add any more, but it could. So let's say this has 5 methods, B will have 5 anyway. If it adds on 2 more, then it's got 7. Now, if you have a B reference, you could call these extra 2 methods that are not up there. So that's when you get that problem. And that's why it'll cause you a problem at runtime. Okay, this particular one, we have a default method in an interface. And then we have another interface extending it. Interfaces can extend other interfaces. And this question really is about, well, what can you do? Okay, well, I'll come back to the first one. Which of the following options can be inserted in the sub interface independent? Can I put in string get ID, given that there's a get ID up here? Yes is the answer. An interface can redefine a default method and also make it abstract. The next one. Yes, an interface can redeclare a default method and provide a different implementation. So here you've got abstract and static. Well, if it's static, it's supposed to have curly brackets. And static methods can never be abstract, either in a class or an interface. So there's 2 things wrong with that. Here, static, no curly brackets, missing them in other words. So that's wrong. Same with the default here. Must have a method body, curly brackets. This one's a little tougher in that trying to override a static method with a non-static and vice versa in a class, okay, will result in a compiler error. If you have a static method in a class, you try to override it with a non-static or vice versa, that's a problem in a class. Even in the cases of interfaces, a sub-interface cannot override a default method with a static method. You can, however, have a default method in a sub-interface with the same signature as a static method in the super interface. Now, We need to evaluate it to have a look at that. They're the right answers, by the way, anyway. I'll just try to evaluate it. Okay, so this is a little tricky, okay? So you can have a static in the parent interface with a default in sub, okay? But not the other way around. In this next question, we have a static method in the parent class, and then we have a static in the subtype, and then we have an instance in the subtype. Now, first one here is class B will not compile if line 1 is uncommented. It says here that it will not compile if we uncomment that. Well, it will compile. Okay, the static method can be shadowed by another static method. So you've got a static method there, and then you can shadow it. So option A here is not correct. Class B will not compile if line 2 is uncommented. That's correct because the static method cannot be overridden by a non-static method and vice versa. Static, non-static, that's a problem. Class B will not compile if line 1 and line 2 are both uncommented. Well, if you've got both of these uncommented, then you've got a duplicate method signature. Not to mind that that's static up there and a non-static. That's the same method signature. Duplicate, the compiler won't know. So therefore, that is a problem. Let's evaluate because the description is a very good example here. Another concept, although not related to this question, but about static methods, is that static methods are never overridden. They are hidden, just like the static or the non-static fields. So for example, here's class A with an instance variable I set to 10, okay? And then you have a static method M1 and an instance method M2. Then you have the subtype B, instance variable I set to 20, static method M1, hiding the one from up here, an instance method M2 overriding the one from up here. Here, unlike M2, M1 of B does not override the M1 of A, it just hides it. As proven by the following code. You've got an A reference called A referring to a new B. And you output A.I, so that's data. So you go to the A reference. What's the A reference? It's a type A, so it'll print 10. Instead of 20. Then you call the M1. M1 is a static method. So again, like the data, you go to the type, which is A of the reference. So therefore, you get the M1 from A. M2 is an instance method. So you go to the object in that case. That calls B2's M2, as M2 is not static. In other words, it's polymorphic. And so it overrides the A version. Okay. Okay, this is similar to the previous one. We have interface value is set to 10 there, and then we have a method M1. Then you have an interface, another one that extends the two of them. You've got an M1, and then you got an M1 that takes an int. There's nothing wrong with this code. I think that's fairly okay. There's nothing there to cause you any particular problems. If you implemented T3, you would have to put in an M1 method and an M1 with an int. So there'd be no ambiguity in your class. You'd be putting in an M1 method. There's no code here. Okay? There's no code to be causing you any ambiguity. The next one is a tough one. Okay, so what's going to be output here? Here we have a test class, and we refer to a sub.id. We have a static block in sub, and sub extends super where there is a static initialization inside there. Okay, so there's a static block in here, and in super, it's not a static block, it's just a static instance variable called ID. Now the answer to this question is that there. So when you say sub.id, you come up Okay, you're referring to ID through the sub reference. And it's a static, so therefore you can do that. Class name dot variable name. Now, it actually doesn't execute this guy. It goes up here and it initializes the ID to QBank. Okay, and it's a very specific scenario. And when I do evaluate it, you'll see that. And it's this particular fella here. This is coming straight from the Java language specification. A reference to a static field causes initialization of only the class or interface that actually declares it, even though it might be referred to through the name of a subclass or subinterface. So we are referring to it, okay, through sub, but it isn't this bit that'll get done. It's this bit up here, the initialization. A reference to a static field causes initialization of only the class that actually declares it, which is super, even though it might be referred to through the name of a subclass, which is sub. Okay? So that's a tricky one. Okay, given the following interface definition, which definitions are valid? Okay, there's the interface there. You've got a class A extends the interface. Well, that's not right, is it? Class cannot extend an interface. That's wrong. Interface I2 extends I1 and puts in a method. That's fine. Interfaces can extend each other. Abstract class B implements I1. Okay, now, an abstract class is not a complete class. It doesn't have to put in any of the methods I1 declared because it's abstract. In actual fact, it's not putting in any of them. You've got a set value with a string, that's not present. You've got a get value with nothing, and this is a get value with an int. So don't confuse that. You could easily think, oh, there's the get value up here. That should be public down here. That's a compiler, but it's not. It's a different method. Yes, it's only package private because it's in a class, but it's a different method, so it's nothing to do with this. This class B is fine. It's not implementing any of the two methods that are up here at all. But it doesn't have to because you're saying that it's abstract. Interface implements another interface. No, can't say that either. So therefore, that's the answer there. So here we have a class create which has throws the doStuff method throws file not found exception. Then you have amazing, which extends great, the doStuff method, which is the same signature instance method. You're overriding it then, and you're throwing IO exception and illegal argument exception. You've got a problem here. Okay, the golden rule when you're talking about exceptions is that the overriding method cannot throw any new checked exceptions. Okay, now this is a broad set of exceptions, of which this is one of them. So this is a parent. End of file exception is one of them. Okay, and then in main we have great G is assigned to amazing G.doStuff. Now the reason that main throws an IO exception is because, well, the compiler is looking at the doStuff from great, and great has a method doStuff which throws file not found exception. Now file not found exception is an IO exception through inheritance, and that is acceptable obviously then for main to declare that it throws IO exception. So we could have used the catch block around the code in main, but in this case, the example given declares that main throws an IO exception, which is the parent exception of file not found exception, which is the exception thrown by the do stuff in great, which is what the compiler is looking at. Okay, so this is a tough question, but it really will tell the difference as to whether you know your exceptions when you're overriding or not. Okay, and we're going to understand that. So let's look at it in the document viewer. So we have IO exception is the parent here. And then file not found is a subtype. And there's lots of other ones. End of file exception. Okay. Now, what we want to do is look at the options. Change the do stuff in amazing to throw only illegal argument exception. Now, when you're overriding, okay, you cannot throw extra checked exceptions, and that's what we've done here. We've gone from a more specific to more general. Okay, so for example, if you think about it again, plug in something that might mean something. This could be Volvo to car. So in the parent method up here, we were throwing Volvos only. Subtype, now we're throwing any type of car. That's a big problem. That is a big problem. Because as you can see here, you've got great. Let's try and explain why this is a problem. Great is referring to an amazing object. Yet the compiler is looking at the do stuff based on the type of G, which is great. So it's looking at this signature here. So what it'll do is it'll make sure that you cater for file not found exception. Now, file not found exception is an IO exception, so that's okay. But I've got a Java program I'll show you now. It'll make it a little easier to understand. That would have been much better if it was just file not found exception. It would be much easier to explain it. But however, the compiler is looking at the reference type. And it's making sure your code behaves properly according to the reference type, which is great. But at runtime, it's polymorphic. It's going to be the do stuff in amazing that's going to be running. And if you were allowed to throw extra checked exceptions in the polymorphic method, then what would happen? Like, the code isn't written for that. The code is looking at the reference type, and the code has been written according to the reference type. Therefore, the subtype methods must not throw extra exceptions that the code will not have been written for. That's the reason why. Okay, that is the reason why. It's much easier to understand it then when you know why there is a problem with this. So that's what we're doing here. We're throwing a, shall we say, a small exception, but now we're throwing more. There's more of them here. Okay. So if we change do stuff in the subtype to throw only the runtime exception, that's okay. Okay, that is okay. It is a very valid thing to do in your subtype to not throw any exceptions at all if you don't want to. That's a valid subset. You can throw the same checked exceptions, one less, two less, or none at all. In this case, we're only throwing runtime exceptions, which don't matter. Compiler doesn't care about them. Okay, so it doesn't matter at all then. So that first one is okay. That will work. The second one, change do stuff in great, do stuff up here in great, to throw a file not found and illegal argument. Doesn't matter about the illegal argument, still got the same problem that you're throwing more checked exceptions here. That's not right. Change do stuff in amazing to throw only IO exception. That's not right because that's the problem. That is the one that's causing the problem. Change do stuff in great up here to throw only IO exception instead of file not found exception. Yes, that will work because now you're throwing IO exception and now you're throwing it down here as well. So they match up. Replace g.do stuff to casting g amazing. That's down here. That's nothing to do with our problem. Here I have a class called base and I've got a method n and there's the file not found exception. Then I have a subtype sub extends base and I'm overriding it. See that one there? All on its own. That's okay. None is a valid subset. So I was throwing file not found up here, throwing nothing down here. That was okay. So what if I get rid of that version and put in that one? That's okay. The exact same exception signature. Next one. That's okay as well because I'm not throwing any new checked exceptions. That's the golden rule. I am throwing any unchecked exceptions. Doesn't matter about them ones. Runtime exceptions, unchecked exceptions. You can throw as many of them as you like. Now I'm going to get a problem. I'm throwing a new checked exception. Base M does not throw the checked exception, end of file exception. Okay. Overriding again. This time I'm going to throw the parent IO exception. Now I'm trying to throw extra checked exceptions. That's very similar to the one that was in the question. Go back to the very first one. Here's base, B is assigned new sub. Now, explanation. The compiler is always looks at the reference type. Remember that. The compiler looks at the reference type. What's the reference type? Base. B is the reference, base is its type. Base in this example. Thus, the compiler works off the signature of M in base. However, at runtime, we are dynamically binding polymorphism to the object sub, because I did a sub there. If the overriding method in sub was allowed to throw extra checked exception that the compiler was not expecting, ... You know, be a disaster. Remember, the compiler has verified the code based on the exception signature of M in the base and not the one in sub. And that's the reason why.